Using the graph at the right, it shows the height h in feet, the small rocket, t seconds of the small rocket, t seconds after it is launched. The path of the rocket is given by the equation h equals negative 16t squared plus 128t. So as you can tell from the graph, it is definitely a quadratic function, which means I have a spot in which it turns around and comes back to the x-axis. So for part A, it asks you, what do the x-intercepts represent in this graph? So if you think about the graph and you look at the graph, the y-axis is h for the height, or how high it is in the air. The x-axis represents time in seconds. So if I have, well, it looks like here's my x-intercept and here's my x-intercept, so where it runs into the x-axis. Both of these points is where y is 0. In other words, it's not in the air at all. It is where it is on the ground. So the x-intercepts represent the times in which the rocket is on the ground. So it starts on the ground, it shoots up into the sky, comes back down, and hits the ground again. So the x-intercepts are the points in which the rocket is on the ground. So points where the rocket is on the ground. So remember, those are also called solutions or roots in quadratics for this word problems. For the word problems, you're going to have to contextualize it and make sure you know what it means in the context of the problem. And for this problem, it is where it's on the ground, 0 feet in the air. What is the approximate maximum height of the rocket? So the maximum height of the rocket is just where we find the maximum point of this quadratic function. So the maximum point of this quadratic is right here. So it says estimate or approximate, so I'm just going to try to, so if I look at 250, so 200, 210, 220, 230, 240. So it looks like they're each going up by 10, these boxes. So this looks to be 260 feet up. So the approximate maximum height, this top height here is just above 250, so I estimated at 260. Part C, what time does the rocket reach its maximum height? So remember that the y-axis is the height, so that's how I found the maximum height. But if it's asking me to find a time, I'm not going to refer to any of these numbers at all. I only care about the x-axis, which that's time in seconds. So at this point, basically the axis is symmetry, if you remember what that is. At this point, it is at its highest. And at this point, 4 seconds have gone by. So after 4 seconds, it is reaching its top height or its maximum height. So what time does the rocket reach its maximum height? 4 seconds.